Okay, the rest
When you
of
have
this
practice after
lesson,
school,
yes?
though,
I don't have
Right.
that.
That's yours.
can't relate.
The rest of this lesson talks about, things called arc length and stuff like that. Yeah, which you should have done in geometry 2 years ago.
Geometry sucks. Freaking hate geometry.
Okay, if you look on
Geometry,
page, let me see. Okay, yes, if you look on the back, or the last page, the back. Okay, we're gonna talk about finding the length of a sector and the area of a sector. There are formulas for these. Okay, to find the length of a sector, you have S equals R times theta, meaning theta, yes. Okay, which is which R is your radius, yes, and theta is your degree. Okay, when it's a central angle. Now, when you're multiplying those together, theta probably needs to be in what form? What form would be theta in?
Ain't theta just a degree?
It is, but when we're multiplying it to find the length of a sector, you're gonna need it in radian
It says
form.
rad, so radiant.
Yeah, you're gonna need it,
Degree, is that?
that's how you put a degree into radian form, yes.
Because you have S
Okay, we
over
got
R.
Okay, so we're gonna talk about finding arc length, and we're going to, do that in a second, but first we're gonna talk about complement and supplement angles, okay? What does complement mean? Do you remember what that word means?
Complement is 90.
They add to be 90. Well, and supplement adds to be
180.
180.
Turn me up, Kylie. Yes, sir.
So if I have an angle that is pi over 12, if I have an angle that is pi over 12 and it wants the complement of that, what would that be?
24. Oh, okay. Never mind.
Definitely not 24.
I tried.
If I have pi over 12 and I want a complement of that, what do you know? What do you know about 180? Or about 90, I'm sorry, about 90. What do you know about 90 in radian form? What is it?
Pi over 2.
Pi over 2. So if that's supposed to have a complement, and it's supposed to add to equal 90, or pi over 2, what do you think we should do to find that complement? Take pi over 2 and do what with pi over 12? Nope.
Multiply by 2.
No. Guys,
Trying to get the comment? I don't know.
yeah, you're on the right track.
Yes.
Okay.
If I have a 90-degree angle, right, and I know that this is 30 degrees, how do I figure out what the rest of this is? We subtract, right? We're going to do the same thing in radian form. Pi over 2 minus pi over 12 will give me my complement angle. So what is your common denominator then?
2.
No,
12.
12.
You got times by 6.
So times this by 6, so this should be 6 pi over 12, yes?
5 pi.
5 pi over 12. There's your complement angle. Good. Good, Stacia, good. So then if I'm finding the supplement angle, what is 180 degrees in radian form? Just pi. So if I'm finding the supplement angle, I'm going to take pi and subtract from it 5 pi over 6. Common denominator is 6. So you have 6 pi over 6, right?
Pi over 6.
Good. And what is pi over 6?
30 degrees.
30 degrees, beautiful. Good job. Okay. Coterminal, what's coterminal mean again?
Share the same.
They share the same, yes, they share the same side. So when you're gonna have a coterminal angle, okay, you're going to have, what am I gonna do with coterminal? What am I going to subtract? If that says 17 pi over 6, okay, think this through. 17 over 6 is going to be like, if I change that into a mixed number, it would be
Mixed number.
12, it'd be 2 and something, right?
2.8.
Okay, so it would be over 1 rotation, correct?
What?
17 pi over 6 is more than 1 rotation around a circle, right? Because a circle is 2 pi, yes? So I'm going to take 17 pi over 6 in this case for the coterminal angle and subtract from it 2 pi. You have to work backwards on this one. okay, because that angle is already larger than a circle. So 17 pi over 6 minus 2 pi. What does that give me? Your common denominator is 6. So you have this, which gives you 5 pi over 6. There's your coterminal angles. Okay? So once again, we have to think through like we did in our homework on Thursday and work backwards from that process. If it's over 2 pi, you have to subtract the 2 pi from what it is. If it's under 2 pi, you're working with either pi over 2 or you're working with pi and subtracting from that. Now, to arc length. Okay, a circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees. How will I solve that?
You do the S equals R theta.
Yes, S equals R times theta,
I like that.
okay? But theta needs to be in what format?
The zero equals, or that thing equals S over R.
No,
Yes,
no.
yes.
Oh, you want to reverse the problem? We don't need to reverse the problem, we're finding arc length. Arc length is represented by S, that is arc length. We know the radius is what? 4. You know the radius is 4, so it's S equals 4 times theta. What does theta have to be in? Can it be in degrees?
Theta. No, it has to be in
It
radians.
has to be in radians, so we need to do what with 240?
We need to put that,
How do you change degrees to radians? Pi it, what do you mean by that? Take 240 degrees over 1, how do I change it to radians? Multiply it by
pi over 180.
pi over 180. Pi over 180. So what is 240 and 180? What do those reduce down to?
Ooh, you can do
63.
24 and 18. What goes into
4 and
24?
3.
4 and 3.
Haha.
So you get 4 pi over 3. So you're multiplying this by 4 pi over 3, yes? What's 4 times 4?
16.
So you get 16 pi over 3. So your arc length equals 16 pi over 3. Put 16 pi divided by 3 in your calculator and you get what your arc length is. 16.8 if you round, 16.8, and it's arc length, right? Inches. That is how we're gonna find arc length. You have to always transfer degrees into radians first, okay? And you transfer them by multiplying by pi over 180 and reducing down.
How come you never do pi over 360?
You don't do pi over 360.
I mean, like, why don't you? Why you gotta do half?
Because, yeah, because we're just working at that point with a semicircle, because if I go one whole length around, it's just pi.
Oh, okay.
Does that make sense?
Yeah.
Okay, now we're gonna do 2 more. I'm gonna do this one first. The second hand of a clock is 10.2 centimeters long, as shown in figure 5. Find the linear speed of a tip of the second hand. Let's talk about how to find linear speed. Okay, linear speed has a formula like this.
A equals 1/2 R squared.
No. Linear speed equals this. It is your arc length over your time. Okay, and arc length is the formula R times theta, yes? Okay, so technically linear speed is R times theta over time, yes? Okay. So we are going to try to solve this, figuring out some stuff. The second hand of a clock is 10.2 centimeters long. Find the linear speed of the tip of the second hand. How can we figure that out? How can you work that backwards? Arc length over time, how can we work that backwards? How can you figure out what the arc length is? Multiply it by something, okay? What does that mean? Do we know what theta is in this case?
No.
Um, yes and no. It doesn't straight up tell us what theta is, but what do you know about a circle?
It's 360.
It's 360, which is what in radian form?
1/1. I mean, pi.
180 times
Pi,
Yes.
okay, it's pi, okay? And it says, so one revolution, right? Okay, we need to talk about what that looks like. What is one revolution in this case then? It's not pi, pi is 180. It's 2 pi. Okay, so one revolution is 2 pi, and I'm dealing with a clock, right? So my arc length is going to be 2 pi times what?
10.
10
No,
point,
10.2. I didn't see the 10.
that's fine. So you're gonna do 2 pi times 10.2 for this, yes? And you're trying to figure out what the time is, right? Well, think about this. A clock tells time, yes? Okay, and you are dealing with,
Are you okay?
I don't know what he's doing. You are dealing with what hand? What hand are you dealing with? The second hand. So how much time goes by when it goes in one revolution in seconds? Good. So we're going to divide by 60 seconds, right? Okay. So we gotta figure that out. So what is 2 pi times 10.2 divided by 60?
It's 4.088.
No, it's not.
No, it's not. 1.1.
Yes, it's 1.068.
1.0681411.
We'll just leave that at 1.068, okay? 1.068. And this is in centimeters per second. Because this up here is in centimeters, this down here is in seconds.
Okay, so how do we get half
Okay.
of these things?
How did we get half these things?
So,
Okay, Cameron,
okay.
the 10.2 is easy because it was on the diagram, yes?
Yeah, that was given.
And linear speed is arc length over time, correct? Arc length means that you have the radius times the theta, the degree.
In this case, our theta was 180, or
No.
was 360.
Was 360 because you're dealing with time,
Okay.
okay? And so you're going one whole revolution, and a whole revolution is 2 pi.
Alright.
So that's where I get the 2 pi and the 10.2. On bottom, it says you were looking at the second hand, which is where I get 60, because there is 60 seconds in a minute. Okay, does that make sense? Is it what? The 2 pi is the 360 degrees, the one revolution. Okay. Last one looks like this. The blades of a wind turbine are 116 feet long. The propeller rotates at 15 revolutions per minute. Find the angular speed of the propeller in radians per minute. Angular speed looks like this. Here's the formula for angular speed. It is the central angle over the time.
Central.
Progress reports came out.
Okay, central angle over time. Okay, so we need to find the central angle over time. So let's talk about that first. Central angle is simply your theta. Okay,
So theta is 2 pi.
well, let's talk about that.
2 pi is
Theta in the, okay, so one revolution is
pi.
2 pi, right?
Oh, I think I have.
No, one whole revolution is 2 pi, 360. How many revolutions are going on? 15. So what is theta in this case? 30 pi.
Okay.
Good station. So you have, for part A, you have 30 pi over, and we need our time. Okay? What's it say, per what?
Minute.
Minute, per minute.
16 hours.
So listen, you're literally dividing by 1 minute. Okay? And this is in feet up here. Because we go by minutes on the bottom of all of this stuff, But if you did seconds, you would have to change it into seconds, or hours, you would have to change it into a fraction, like into something, okay? So then we get 30 pi radians per minute for our angular speed. It's literally that easy. Oh yeah, this is right, sorry. Okay, now for part B, it wants the linear speed. What is linear speed again?
Arc
Arc length over time.
Arc length over time. Okay? Once again, what's our time? 1 minute. Okay? What's our arc length?
116.
116 times,
Pi.
how many revolutions did we do?
Oh, wait. 15.
Well, we did 15 revolutions at 2 pi, which gives you 30 pi. So you're gonna take 116 times 30 pi, yes? Okay. And this is in feet because your arc length is always in whatever measurement you're working with. So you do 116 times 30 pi, and then divided by 1 minute, which clearly when you just multiply those out, you should get 10,932.7,
32.74.
but it's feet, so we have to round up because you can't have 0.7 of a foot. So 10,933 feet. Feet per minute is what it's rotating at, okay? So everything you are doing tonight is formulas.
Yes.
I would suggest writing all the formulas out and then just working from there so that you know what you're working with. It's all formulas.